Our third speaker is Sina Zalbegi from Islamic Azad University by the title of Designing and Constructing of Membrane Photobioreactor for Cultivation of Microalga for Aquaculture Wastewater.
Much for participating, and first off I have to thank the organization. My name is Sina Zalbegi and I'm from Iran, Islamic Azad University. The project that today I would like to talk about is actually a part of a very huge project that has been conducted for 1 year and a half. It's kind of like a joint project between the Islamic Republic of Iran and also the University of Tehran. I'm just the representative of this project specifically, and unfortunately because the other authors couldn't be here, so I'm just going to be the representative of the project. And as we can see, the project is titled Designing and Constructing a Membrane Photobioreactor for specific cultivation of microalgae for aquaculture wastewater. And specifically by aquaculture, we are talking about the rainbow trout aquaculture. And the authors are Mr. Mohammad Mirarefin, and I'm going to be the second one, but however, it is kind of just like the representative thing. Ms. Shahrzad Ismaili, Yasamin Khanifar, and Ghazal Baghai, and also under the supervision of Dr. Farshid Pajum Shariati and also Dr. Omid Tawakkali. For the sake of this conference, first we're going to have the introduction, and also then we're going to stick with the materials and methods, and then we're going to talk about the result and discussion of this article, and then we're going to talk about a few conclusion and kind of like features of this specific project in the future. To the very first beginning, I have to say that aquaculture is kind of like a growing sector of agriculture, and according to the research conducted in 2020, by Dr. Murray John, there is an increase in aquaculture production by 60% into next 20 years. And as we all know, when the production is higher, so of course the waste is going to be higher as well. So that's kind of challenging because as we all know, fishery industry is kind of like very different and vary type to type. So we are facing with different type of wastewaters, and while we are talking about the warm water fish, cold water fish, marine fish. So it's kind of like complicated, challenging, and we are facing with different compounds and components. So technically, when we are talking about the wastewater of aquaculture, we need to be very specified. And in here, we're talking about only about the rainbow trout aquaculture. As you can see, nowadays, unfortunately, most of the wastewater coming from the aquaculture sector gonna left untreated, and they're gonna just disperse to the lakes, rivers, and everywhere else. So we need to move an action and make an action on it. So that's the problem, and the solution would be, well, for the sake of this conference, would be the microalgae. And according to the consumption of the microalgae in the fishery industries, there is a promising solution that we can use these specific creatures, these little creatures, as the fish feed supplements, or maybe part of their supplement, or maybe by just making the thing more sustainable by removing the contaminants of the wastewater, and then return all those wastes consumed by the microalgae to the industry as a feed. So. Yeah, the wrong bottom. Okay. So, the specific microalgae that we actually use in this project is Chlorella vulgaris microalgae, and as we all know, in the whole concept of microalgae, we got very, very different types of them, and we know in aquaculture mostly we're going to use the spirulina type, but in this specific project, due to the other concept of the article, we use Chlorella vulgaris in two main factors. Number one is the availability of microalgae, this type of microalgae in our country, and the harvesting situation and cultivation situation in Iran. So the best type would be Chlorella vulgaris microalgae. According to the equipments and analysis and also the materials that we used, I have to say that as we all know, microalgae needs a specific type of things for just grow like enough CO2 and everything else, and one of the most important one would be the photobioreactor that we're going to use, and we all know it's going to be separated in two kinds, like the open pounds and also the closed systems. So we're going to specifically talk about the closed ones because we know the disadvantages of the open pounds, so we're going to stick with the closed ones. As we know, microalgae has shown that they have the ability to remove the nutrients and other pollutants from wastewater. And the biomass obtained from the wastewater treatment is more and more recognized as a sustainable source of the various products in the future, like products like cosmetics and also pigments and biofuels. So various technologies has been reported for the cultivation of microalgae, and the cultivation method is more influenced by the type and the strain of the microalgae and the application that we're going to have specifically. But about the disadvantages and advantages of the photobioreactors, very quickly I would like to mention that the advantages of the closed systems would be that they are kind of like a satisfactory mass transfer, high surface to volume ratio, and good mixing with low shear stress and efficient mass transfer, and ideal for microalgae immobilization. And the other disadvantages of the open systems, because technically we just worked on the PBRs in this specific presentation, is that the open pounds require a large space, they're going to be like time consuming, they're going to be like contaminant and different things. So technically we're going to stick with the photobioreactors in these specific presentations. The wastewater used in this research is the wastewater of the aquaculture industry, rainbow trout, as I said earlier, the main actually compounds including this wastewater is nitrate and phosphate, the total nitrate and phosphate. And the membrane we used in this specific research is Kubota, made by Japan, with the type of PES. And also the aeration was via an air blower with the flow rate of 80 liters per minute, sorry. And also the permeate was for the MPBR actually, was via a peristaltic pump with a flow rate of 1 to 3.5 liter per hour. And also for the, actually according to the membrane fouling, to check the membrane fouling, the pressure difference of both sides of the membranes is measured. And for the pH analysis specifically, we used the pH meter known as HI207. And for the Chlorella vulgaris microalgae concentration analysis, we covered the OD analysis via the spectrophotometer known as UV2100, and actually the wavelength of 680 nanometer. According to the membrane resistance measurements, this analysis is done by using peristaltic pump, TMP device, and a computer system. When the pressure difference between the two membranes reaches to 250 to 300 millibars, the operation of removal, or actually better to call it the cleaning of the membrane in both physical and chemical way has been conducted. Okay, I think I'm done with this part. Yeah. The bottoms are a little bit challenging. So. Yeah, that's true. And the novel thing about the whole project is designing the membrane photobioreactor specifically. The membrane has located vertically in the middle of the photobioreactor with two spargers on the bottom for both physical removal of the cake layer and everything else, and also for a better aeration and circulation of the water. And then the duration or the whole experiment design has been conducted for 11 runs. And as I have to mention this one earlier, the nitrate compound in the wastewater that we used was mostly in 77 ppm. So the runs will be categorized in 11 categories, and we specifically wanted to know the difference and or the influence of the different type or different amount of phosphate with the same amount of nitrate in the application. So technically, as we can see in here, the different dose of phosphate of 11 ppm, 21 ppm, and 1 ppm has been collected, and we remained the nitrate amount to 77 ppm. And as you can see, the phosphate of 21 reached the higher dry weight. And in here we have a diagram of nitrate and phosphate removal and also nitrate and phosphate concentration. I'm talking about the total nitrate and phosphate. And as you can see in all 11 runs, when we look at the nitrate removal chart or diagram, we can see on the 6th run that we already talked about it earlier. We had the highest amount of nitrate removal, and also in the run of phosphate, we had the highest amount of phosphate removal on day 8. I need to use my cheat sheet in here, sorry for the conclusion. Yes, and for the conclusion, Chlorella vulgaris microalgae in this research went through its growth period during the experiment, and by applying more nitrate and with it's more actually adding phosphate to the Chlorella vulgaris microalgae cultivation had a better result. And also with the increase of nitrate, the maximum concentration of Chlorella vulgaris microalgae has also increased. The average removal rate of biological and membrane system for nitrate is 74% and 85% respectively, and also the average biological of membrane system removal for phosphate is 67%. And the largest share of total resistance is related to fluid resistance, cake layer resistance, and absorption resistance, respectively. I think I still have a few minutes, right? Yeah. So for the sake of this specific project, because technically it is part of a huge application for a year and a half. The main aspect of the project is designing a photobioreactor that can actually remove nitrate and phosphate or maybe more efficient way, and also CO2 removal. So specifically, we are working on designing the photobioreactor, which actually is not officially finished yet, and we are still working on it. The results are showing that the actual removal of nitrate and phosphate is kind of considerable, so it's kind of like promising. We are still working on it, and we hope it goes somewhere good. And according to the industrialization of this product or this specific membrane bioreactor, we are working of a multidisciplinary application of nanotechnology, chelate compounds, and also microalgae to convert these kind of wastes to something valuable like marine fish supplements or aquaculture fish supplements. Thank you so much for your attention. That's all for me. Thank you.
Do we have questions?
Okay. Sina, thanks so much. I was wondering, is the removal efficiencies in alignment with the discharge levels in Iran? Are you achieving, getting over those limits?
We are not actually getting over the limits technically. We are still working on more efficient ways, but no, not yet. I cannot say officially that we have conducted or we reached to the level, but no, not yet. We are still working on it, and it's kind of like an unfinished project that we need to just work on it more. Yeah.
The reactor was operating in batch mode, right?
It is batch, yes. It's a batch reactor, but we are working on making it continuous type of thing. But kind of it's like it needs a lot of work, and we need to still work on it. But nowadays it's just batch form, yeah.
Great. One last question. Sorry. In aquaculture industry in Turkey, we're also having issues with some drugs that are also introduced into trouts and everything. Do you have similar issues other than the nutrients? Is there anything that algae can help remove in aquaculture wastewater?
Yeah, that's an interesting question, and that is true. In Iran, we have the same problem. The base is kind of like containing billions and billions, the other kind of things that algae cannot support on removing it. And technically, in this project that we have conducted, it's kind of like the second treatment of the wastewater. First, we use the microfiltration for just microorganism removal, and then we use the synthesized wastewater for this specific application. But yes, we are having lots of challenges with the wastewater of aquaculture specifically.
Thank you so much.
I think.
I have one question, please.
Okay, we also have another question.
Yeah.
Yeah, sir.
Sorry.
Okay, listen.
Thank you. It was very insightful, but I know that increased levels of nitrogen and phosphate in water can lead to algae blooms.
Yep.
So that's a risk here.
That is
I don't know
true.
if you considered that in your study. And
That is actually true. This is the actually third phase of our project. Algae bloom can be quite terrifying, and when we are having an increase of it. Technically, recently we are working on the biofilms, and we are trying to control the algae bloom. This research will be conducted by the University of Toledo, USA, Ohio. It hasn't been started yet. In summer, we're going to start the application of the biofilm and using the application of microalgae for removal and considering it as a kind of like problem or issue in this category. It is not officially started yet, but this is on our plan for phase 3 that we started. Yeah. I think that's it. Thank you.
Thank you for your presentation, Sina Zalbegi.